Hello, everyone. Thanks for tuning in. Today I have a short follow-up to my pulsing tubes tutorial. I'll provide the link in the description. Today we will just be doing a quick look into how to render something like this in Solaris and how I created the render you are seeing now using Karma XPU. So let's get into it. Okay, so here's where we left off with our scene. We had created these lines that have this pulsating animation running through them. And so now we want to bring it into Solaris for rendering. So first things first, let's go to our menu right at the top here and click on Solaris. So here we are in the Solaris context. And for those unfamiliar, Solaris is Houdini's new lighting, layout, and rendering type context. It is all USD based, but during this tutorial, I'm simply showing how to get something into Solaris in order to use Karma XPU, just kind of the simple way to get you started, and I'm not going to be going into any USD specific workflows. The first thing that you have to do is actually get your objects into this stage context. So before we were working in the object context, and now we are in stage, which is Solaris. And so the first thing you do is import your geometry from the object or SOP context into here. And you can do that with a SOP import. This is very much like an object merge in the object context, and you can simply path it to whatever node you want, and it will import that object. So here we're pointing to the object line render null, and if I jump to that, here it is, and it's just at the end of this chain that we had created in part 1 of this tutorial. And then the next thing I do is a SOP create node. This allows you to dive in and do anything you could in SOPs within the stage context. So here I'm just making a simple backdrop, a cyclorama type curved surface, similar to like a photography studio. So you can create a grid, bend it, and subdivide it to easily create something like that. And then I just moved it in place using these object transform nodes, just like you would with any other object. And you can see over on the left here, what's happening is each node in Solaris is populating this scene graph. So you can see this is curves that was imported from here. And then when I click on the ground, we now have the ground populated into the scene graph. And so this is kind of like the outliner in Maya, or just a general organizational list of everything in your scene, and it gets populated as we create these nodes. So this is essentially what all these nodes are doing. It's a little different thought process than SOPs because the order doesn't matter. I can go ahead and put the ground up here and the curves below it, and I'll get the same scene graph. These don't necessarily directly affect each other. So now I have the ground and the curves, and I want to put some materials on them. So to do that, we can make a material library, which is essentially like a mat net or a material context. And we can jump in there, and I've already made the materials used for this scene. I have a material for the ground, a material for the curves, and then a material for the camera lens, which is fun to play around with. So to make one of these materials, you can lay down a Karma subnet, if I can spell it right, Karma Material X subnet, and dive inside there. And so this is very similar to a material builder type setup that you would find in Mantra. It comes with this BSDF node here, but for Karma XPU, I think at this time just the standard Material X is supported. I don't think you can break it into these separate BSDFs yet. So to put that down, we can type in Material X, and we have this, let's see, actually I'll type in standard, MTL X standard surface. So this is very similar to the principal shader in Mantra or the standard Disney type shading model where you have metallic roughness. So if you're familiar with that, you'll probably be very comfortable with setting this up. we can pipe that into our surface output. If we had anything for displacement, we could pipe that into our displacement output here. For this example, if we jump into the actual material, I'm just using this USD primvar reader to read in this loom attribute, which we created in part 1. So this USD primvar reader is very similar to the bind node in within the principal shader, or the standard VOP approach in Mantra. So you can use this to read in any attribute you want into your material and have it drive the attributes on your Material X shader. So here I'm routing in this loom attribute, which was simply this white to black gradient. If we jump back to our SOP context and look at that, I can preview that. So it's just this gradient, and this might be easier to see without the lighting. That runs from 1 to 0, so the purple is 0, and then this area is containing the loom attribute. So we're using that to drive all the shading within this network. And I've noticed I have this reverse node here. I noticed I was having some transmission problems because I had created a glass material, and I found that it seemed to behave normally when I actually reversed these faces, even though they appear backwards here. Something to investigate. I'm not sure if that's just a side effect of Karma XPU, but worth noting. All right, so let's jump back to the stage context and see what exactly is going on with the curves material. This loom attribute is simply routed into transmission, as I alluded to. So this is mostly just like a glass-like material, and then I also routed it into emission. So that's what gives us these like bright yellow streaks across it. If I go ahead and switch to the Karma viewport here, you can see we're getting these yellow emissive streaks driven by that loom variable. So I can go ahead and click this button just to maximize my viewport. And I'll switch back to the Houdini GL renderer. So once you have your materials created, you have to actually apply them to the geometry. You can do this within this material library context, but I like to create this separate assign material node to actually apply the materials onto the objects. And so to do that, I'll recreate it here. An easy way of doing this is if you look at this scene graph we've been composing, you can just simply click and drag up to these menus. So for material path, I can grab this curves material that has been populated into our scene graph, and then I can grab our curves primitive and drop it in the primitives. And now you can see it's this, you can barely see it because it's transmissive, but we have the material assigned to curves. And now if we want to add another material, I can click two materials and then apply the ground to the ground. And so now all my materials are assigned. I have this flat green type shader for the backdrop and this glass-like material for the tubes. And so the reason I like to use this assigned material rather than using the material library assignments is you might want to make almost like a global material library. And if you have a bunch of materials in here, you could theoretically put it at the top of your node graph here so it's available for everything in your scene. So as I said in the beginning here, the order of these nodes doesn't function the same way as SOPs. So you can put your material library right at the top of the list. And then the one way it does matter is the assigned material does have to go after these objects, because otherwise they wouldn't be populated in your scene graph yet to actually assign a material to. So this allows you to have access to the materials for everything in your scene. So you could technically make more branches off of here for different shots and still have this information available. I'll go ahead and just put it back right here though for this setup. since we just have this one shot. All right, so the next thing you want to do is get a light in there. So with this render from part 1, all there is a dome light, and that is just using a simple HDR to light the scene. I didn't do any specific lighting for this render. Very simple. And then you can make a camera, and this functions very similarly to how it would in any other renderer. I can switch to the camera view, and then on this drop-down menu, press Karma to start getting a live IPR feed. And so you'll notice that we have all this noise, and this is because I've been playing around with some of the camera's physical lens attributes. So I have actual chromatic aberration happening within the camera rather than doing it in post, which increases render time a little bit, but it's interesting to play around with because it gives you a more physically accurate chromatic aberration in the defocused areas with depth of field. And so to make that physical lens shader, if I jump back into our material library, I have this physical lens. And so if you just search for it, we can put down this Karma physical lens. And within this shader, you have options for the bokeh, and the lens distortion, the tint, tilt, shifting, etc. So you can use this to kind of do some post effects within the render itself and bake it into the render if you so desire. To assign that to the camera, you can simply go to this Karma submenu on the camera and point it to the location of that material. And so I have it pointing to the physical lens 1, and then there's that physical lens 2 that we made just now. And then when you're ready to render, you can set down a Karma ROP. So if I go ahead and lay down the Karma, it'll automatically populate it with Karma render settings and the USD render ROP. And then you can pipe that in. For Karma XPU, you'll need to change this CPU engine to the XPU engine. And then you can do things like go to the image output and filters and turn on denoising, which is nice if you just want a quick render with low samples. You can get pretty clean settings. So here this frame took 18 seconds without denoising, and it looks pretty noised up. And if I go to the render Karma node I set up before, I have the denoising setup, and I've upped the filters, so it should produce a cleaner image but with slightly longer render time. So I'm not going to sit here and watch it render, but you can play around with the balance between your path trace samples, and then you can get away with getting this fairly low with denoising, albeit at the cost of some accuracy, and you might get some artifacts if you really push this low and you're relying on the denoising to clean up the image. So you can balance that for these quick tests to get faster results depending on what you're aiming for. And then the output picture and all of these settings are very similar to what we're accustomed to with Mantra. And then when you're ready to render, you can just hit render to disk and you're done. Okay, so let's look at how I created the actual artwork at the top of this video. So it's a very similar Solaris graph, and before I walk through that, I'll go ahead and show the procedure for creating this. One useful thing to do is to click this pin up here, and that'll keep your Solaris render view pinned, and then you can jump back into the object network and adjust your SOPs while doing a test render, for instance. So let's say I go here and I'm just previewing the light, and I'll mention if you don't have a Karma node put down and set to XPU, one way of previewing an XPU before you set that up is pressing D over this viewport, and you can change the Karma tab here to XPU. By default, I believe it is set to CPU. So when you switch that and you press Karma to render, this'll, so this is the leftover that we were working on before. And so it'll automatically kick in a Karma XPU GPU render, and you can tell the CPU has kicked in, so the CPU is at 100%, and now the GPU kicked in when you see this optics render start ticking up. So it uses both the GPU and the CPU when rendering. And so now, since I've pinned this, I could theoretically go back to the object context, and here's the volume trails that I've created. And so to create that, I actually took, I'll jump back into my standard layout here just to show you this. To create this, I actually took the rocket smoke from one of my previous videos. So here we go. So this rocket test, which I will link in the description. And I've used the volume trail, which is very nice for creating these abstract type of lines in space. And so this will take a minute to cook because it's a lot of lines. And so you get something like this, and it's hard to tell exactly what's going on looking here, but essentially I've scattered a bunch of points in this volume, and you can use a scatter node to do that. And when you pop in that to the first input of the volume trails and then put a volume in the second, it'll trace the velocity out of the volume. So this is a useful method for actually debugging the velocity of your volumes, but it can also create these cool looking abstract lines. And so what I did was just throw on that pulse animation setup that we had created in part 1. And for this one, instead of sweeping the curves, I create a width attribute. And so at render time, the geometry will be created very similar to Mantra. So these will just be rendered as lines with a 0.004 radius. Or diameter, actually. I forgot which that gets applied to. But either way, that'll control the width of the lines. And so that's the setup for this. So very simple SOP setup to create a pretty interesting and detailed line formation. And so let's jump back into Solaris. So this is the geometry we're importing into Solaris in this example. And I'll jump back to stage here. And so just like before, I have the trails being SOP imported, just like so. Then I have a ground plane, the same exact setup from the first one. And then I make the material library. And so in this case, the trails material is a little different. What I've used is the Karma hair shader. So this is nice because it does work with the Karma XPU. And what I've done here is use that same loom variable using the USD primvar reader, and I'm piping that into different attributes of the hair. So I'm really not using this hair like realistic hair shader or anything. I'm just stylistically changing attributes of it with that custom variable that we created in part 1. And so what that does for you is create that sort of lighting variation throughout the shot. So it's a little bit different application for the same setup, which is what Houdini really shines at, is taking one thing and just applying it to another. So then let's view that with the lighting. And so you get this interesting swirl formation with this kind of vortex look. And so when I scrub the timeline, since that is animated, it's hard to tell in just these IPRs, but there'll be this lighting shift throughout the hairs based on that attribute, which you will see in the intro. And maybe I'll just throw that up right here so we can see how that looked in the render again. And you get this nice lighting variation happening within the shot. So you get pretty fast feedback with a lot of geometry, and so it's nice to be able to get this feedback and still be able to adjust lighting and everything. And so this is also a fairly simple lighting setup with a dome light and just this area light that is put back here to get this kind of light streak through this kind of hair donut thing. And then the only other thing to mention about this shot is that I use the same chromatic aberration and defocusing, which you can do in post, just kind of playing around with that sort of stuff right now. And so I did this vertigo type effect dolly zoom by simply keying the translate and focal length. And so this effect is, if you're not familiar, it's based off that Hitchcock effect in Vertigo where you dolly the camera while changing the focal length, and you get this interesting compression of space where this middle part stays in focus, but the whole background is sort of distorting in view. So just a little effect to throw in there to add some interest to the promo art. And there you have it. That's the volume trails. So just to recap the general principle, use a SOP import to import anything you make in the OBJ context. Use a SOP create if you just want to create something in this Solaris network. Use a material library and then an assign material to get the materials. And then you can go ahead and pipe in all the lights you want. You can either put them in line, you can merge them in to your graph. It'll functionally do the same thing by creating this scene graph. And you'll notice by default, these graphs are mapped to the name you give the node, and that's due to this $OS expression. So if you keep that and you name your nodes relatively well, you will have a more logical scene graph hierarchy, or at least a more readable scene graph hierarchy. And so that will do it. Hope you enjoyed this quick start tutorial for Solaris and Karma XPU, and hopefully you'll be able to make some awesome art using these techniques. Hope to see you again soon. Have a great day.